This video is made for those who want to know absolutely every setting of their radio transmitter running on EdgeTX firmware. We'll talk about the meaning of every menu, every button, and every function. We'll create a unique voice pack for our radio. We'll figure out what packet rates and telemetry ratio are, and why you should disable the ADC filter in the settings. How to control one drone with 2 pilots. What to do if a switch doesn't respond to commands. I'll tell you what's important to pay attention to when choosing a used radio transmitter. How to properly calibrate it and safely flash its firmware. We'll learn how to calibrate the battery, and many other interesting things await you in this awesome video. For those who value their time and want to get a complete theory course on FPV without looking for questionable information from different sources. Especially for you, I have created my second large-scale exclusive course of 13 lessons on theory and engineering, totaling 7 hours of highly concentrated information that every FPV pilot must definitely know. It is essential for those who are starting their journey in FPV and for those who need to improve their already acquired skills. In it, we will figure out the selection of ideal components for your current tasks. Save your time and money by using only what you really need, without disappointments and wasted resources. FPV is primarily about attention to detail, and for this, you need to have a large theoretical knowledge base. For this, we will examine in great detail the important characteristics of each component in the drone down to the atomic level from the scientific point of view of physics, radio engineering, and engineering, with the subsequent logic of combining them together with practical lessons on their proper connection. We will learn to read engineering maps and diagrams. We will thoroughly explore drone programming for its correct and reliable operation. Therefore, dive into this exciting world of FPV with an incredible and extensive FPV course from beginner to pro. To start flying your favorite drone, you first need to know how to properly set up your radio equipment. What's the first thing you should do when you get a new radio transmitter? There are 2 options: update to the latest firmware version or leave the one from the manufacturer as is. In most cases, a firmware update fixes bugs from previous versions, which helps to improve connection stability, adds new features for a better user experience, and so on. The firmware serves as the interface for the user to interact with the radio transmitter and control the drone. There are 3 main firmwares for radio systems. Among the most popular are EdgeTX and OpenTX. EdgeTX is the primary open-source firmware with a large user base. Most radio transmitters on the market support EdgeTX and come with it pre-installed, making it easy to transfer settings to a new radio when upgrading. EdgeTX has rich customization options and supports many different control protocols. Additionally, it has a touch-screen-friendly interface. OpenTX is the parent platform for EdgeTX, providing the core functions that are also present in EdgeTX, but without some of the newer improvements. Although OpenTX was once a popular firmware, it has fallen behind EdgeTX in terms of functionality. OpenTX firmware can be flashed to EdgeTX. There are also other firmware options, such as FreedomTX, which is based on OpenTX and is used in the TBS Tango 2 and Mambo, as well as the latest FRSKY radios that use Ethos. However, these firmwares are specific to certain radio transmitter models. In any case, they share a similar logic, so having any of them on your radio will allow you to quickly get your bearings. After reading many forums, I decided to update the firmware to the latest version on my new Radio Master Boxer radio. To check the current firmware version, press the System key, then the Page key, and go to the last page, number 7. My firmware version is 2.8.4. As of today, version 2.10.6 is already available. Before updating the firmware, it is essential to make a backup of the current firmware and its settings, just in case. To do this, turn on your radio. Then, connect a cable to the USB port on the radio itself and to the computer. Using the scroll wheel, select USB storage from the list. Access the flash memory of your radio. Select all the files that are there and copy them to your computer. For example, I'll create a backup folder on my desktop and copy everything into it. Now we have a backup just in case. Now we need to get the new firmware version. Go to the website buddy.edgetx.org. Next, select the latest EdgeTX firmware Centurion 2.10.6. This is the 6th and latest official firmware release to date. Then, I select my model from the list. In my case, it's the Radio Master Boxer. Next, we have two options for how to flash the firmware. Let's look at both of them. The first option is using the online flasher. To do this, you need to turn off the radio completely and connect the USB cable to it and to the computer. Click the Flash via USB button. The most important thing is that STM32 bootloader is displayed. If something else is shown, you need to select it from the list of devices connected to your computer. Then click Next and start flashing. The radio is now flashing, and it's best not to touch it. All done. The radio will reboot, and let's check if our radio transmitter has been flashed. Press the System key, then the Page key, and go to the last page, page 7. We can see that our radio has been flashed to the latest firmware. Let's consider the second flashing option if the first one didn't work for you. Go to the buddy.edgetx.org website again. Next, select the latest EdgeTX firmware, Centurion 2.10.6. Then, from the list, I select my model. For me, it's the Radio Master Boxer. Now I click Download Bin. We save this firmware to our computer. Next, turn on the radio transmitter and connect it to the computer via a USB cable. On the radio, select USB storage. Access the internal memory of our radio transmitter. Find the firmware folder. And into this folder, copy our downloaded firmware. Then, turn off the radio transmitter. Disconnect the USB cable from it. Now, pay attention. We need to put the radio transmitter into bootloader mode. To do this, you need to bring the two horizontal trimmers towards each other and, at the same time, press the power button. Using the scroll wheel, select Write Firmware from the list. Then, from the list, select our firmware version. Next, press and hold the scroll wheel for a few seconds. The flashing has started. Done. Press the Return key. Then exit. The radio transmitter will reboot, and that's it. Congratulations, you've updated your firmware to the latest version. After updating the firmware, it's important to note that the sticks on the radio must be recalibrated. To check how well the radio transmitter is calibrated, you need to go to the initial screen of the radio. Then, using the Page key, navigate to the channel's monitor menu. Here, we can see how our sticks are calibrated. For all control axes, the values at the extreme positions must be 100 or minus 100. We can see that my sticks don't quite reach the value of 100, and we see that the roll and pitch axes are not at 0 when centered, so the radio must be recalibrated. Flying in this condition is dangerous, especially since the throttle stick isn't at its lowest value. To calibrate your radio, you need to do the following. Go back to the main menu of the radio. First, it's important to set the trim values to the center position for all 4 axes. Then, press the System key. Using the Page key, go to page 6, titled Hardware. Then, press Calibration, and enter again. Actually, for proper calibration of the radio transmitter, you should not move the sticks in a circle as many people do, but only up, down, and left, right until you feel a slight resistance at the endpoint. There's no need to press hard to the edge of the stick's travel. You wouldn't do that when flying. By the way, for calibrating a radio on the FreedomTX firmware, you actually do need to rotate the sticks in a circle. And so, we begin calibrating the radio on the EdgeTX firmware. We set the left stick on the screen exactly in the center as shown in the picture. Press Enter. We have no timer, so there's no need to rush. Let's start with the left stick. Calmly move it up to the point of slight resistance, and then down the same way. Pay attention to the stick square indicator. If the radio is working correctly, it should go past its outlines. Now, return the stick to the center point and do the same thing to the left and to the right. That's it. The left stick is calibrated. Do the same procedure for the right stick. When you are finished, you need to press the Enter key. Now let's check if we've calibrated the radio well. To do this, we go back to the main screen. Then, using the Page key, we go to the Channels Monitor menu. Here we can see how our sticks are now calibrated. Now we see that all sticks show the value 100 or -100 at their extreme positions. To finally verify the radio's calibration, there is one more check. In this same menu, you need to move the sticks to the corners and see if the values there are 100 and -100. If you are buying a used radio transmitter, you must perform the calibration we've just discussed and add one more verification step. In this same Channels Monitor menu, slowly rotate the stick in a circle along the edges from corner to corner in any direction and watch if the bar starts to jump erratically. If it jumps, it's a sign of a faulty stick, most likely a mechanical issue if calibration didn't help. If everything works smoothly and nothing jumps, and all maximum values reach 100 or -100 without effort, congratulations, your sticks are fine. After calibrating your radio, it's important to set up the model you'll be flying. Some people might have many drones with different settings and functions, so it's more convenient to have specific settings for each model. Others don't bother and fly with the default starting model, and that's fine too. But for you to master your radio completely, let's create a new model and start setting it up from scratch. To create a new model, press the Model key, then select any free slot. Choose Create Model. Next, press the Page key and go to the Setup menu. Model name. This is the name of the model you will be flying. I'll name it Nazgul after the frame, so I don't get confused about which drone this model profile is for. Once you've typed it in, press the Return key. Timer 1, Timer 2, and Timer 3. These are 3 configurable timers that you can program according to your needs, which will be displayed on the main screen of the radio transmitter. This is for those who want to control their drone's flight time to know how much they've flown today or in total. The timer runs continuously from the moment the radio is turned on. But you can, for example, assign a switch like SC, which is responsible for arming and disarming your drone. This way, you can find out how much time has passed since you started the motors and flew. The most interesting part is that this time is announced by the radio's voice assistant. The timer starts counting when the configured switch is activated and ignores the switch's position after starting. Throttle second. Counts time from the moment the throttle stick is raised above 0%. Throttle percent. The timer counts proportionally to the value of the source selected for throttle control. It is calculated in real time at the maximum value and at 50% of the maximum value of this source. For example, when the throttle stick is at maximum, the timer counts in real time, but if the throttle stick is at 50%, the timer's counting speed slows down by 50% relative to real time. This is useful for those who want to know how much time the drone was really being pushed hard. Throttle start. The timer starts if the value of the source selected for throttle control is greater than the minimum, for example, when raising the throttle stick and activating the selected switch. After starting, the timer will no longer react to this source and will continue to count until the selected switch is deactivated. Out of the 3 timers, I managed to set up 2, one for the total flight time and the second for the amount of time I was flying the drone with more than 50% throttle. The third timer doesn't fit in the window. Next, you can give the timer a name and set the time from which it will start counting. Persist means saving the settings after turning off the radio. To save, select the flight value. Minute means whether the assistant will announce the time. I suggest turning it off because, honestly, it's annoying and sometimes even startling. Countdown is for those who need a countdown timer. Silent. No notification is given until the timer reaches 0. When it reaches 0, you will hear a single beep. The radio will beep every second, starting from the designated time. The radio will start announcing the countdown by seconds, starting from the set time. Haptic. The radio will vibrate every second, starting from the designated time. Beeps haptic. The radio will beep and vibrate every second, starting from the designated time. Voice haptic. The radio will announce the countdown and vibrate every second, starting from the designated time. Extended limits allow you to increase the range of the channel outputs. Typically, the standard channel deviation range is 100% from -100 to 100. Using extended limits allows you to increase this range, which can be useful for certain models or configurations that require greater precision or a wider range of travel. Extended trims allow you to increase the maximum value of the trim settings from 25% to 100%. This helps you achieve more precise control of the model, especially if you need to make larger adjustments. Trims are the sliders that allow you to fine-tune the drone's control, but later I will explain why it's better not to use them at all and to disable them. Reset. If you press and hold the button, it resets all trim setting values to 0. Show Trims is responsible for displaying the trim values on the main screen of your radio transmitter. When this option is enabled, you will be able to see the current trim settings for each channel during flight or setup. If disabled, it is not displayed on the main screen. Change displays the numerical value of the trim deviation. Trim step defines the size of the adjustment step for the trims. This determines how large or small the changes will be with each press of the trim switch. The trim step size can be configured to your needs. Coarse, a step of 1.6%. Medium, a step of 0.8%. Fine, a step of 0.4%. Extra fine, a step of 0.2%, the smallest step. Very precise adjustment. Exponential is a step of 0.2% near the center, and the step value increases exponentially as the distance from the center increases. Throttle allows you to configure the throttle stick source. Reverse. When this option is enabled, the output signal direction of the configured throttle channel is inverted. That is, the throttle stick will work in reverse, from top to bottom. The source that will be used for the throttle. Trim idle only. When this option is enabled, the throttle trim will only affect the lower part of the throttle range. For example, with trim idle only enabled, the throttle stick value at its lowest point might be -80, while the center point will be 0 and the highest point 100. Without this option, the throttle stick value at its lowest point might be -80, but the center point would be 20 and the highest point 100. Trim switch. Using a trim switch, you can precisely adjust the position of channels like ailerons, elevator, rudder, or throttle for optimal flight. Setting up a switch allows you to quickly change trims during flight without being distracted from controlling the model. You can choose which specific switch will be used for trim adjustments. This allows you to configure the radio transmitter to your personal preferences and habits. Pre-start checks. Every time a new model is loaded, EdgeTX performs pre-flight checks based on the settings specified on this page. If any of the checks fail, EdgeTX will provide the user with an audible and visual warning that must be acknowledged before using the model. The following pre-flight checks can be configured. When this option is selected, the model notes file will be displayed when the model is loaded. A valid model notes file must be located in the models folder on the SD card. The model notes file must be in TXT format and have exactly the same name as the model6.txt. The text in the file can be whatever you need. Now, when you turn on the radio, a checklist window will appear so that you definitely don't forget to do something with the drone before flight or to read its specific features. I've heard some people even insert a prayer. Interactive checklist. This option is used with the checklist display option. When selected, any line of text in the checklist file that begins with the equals symbol will be displayed as a checkbox when the checklist is shown. All displayed checkboxes must be ticked to close the checklist. This way, you will definitely not forget anything before the flight. For example, selecting the transmitter power, attaching propellers, checking the battery charge, and anything else you write in there yourself. Throttle warning is used to ensure safety when turning on the radio transmitter. This warning is activated when the throttle stick is not in its minimum position when the radio is powered on. Most flight controllers already have a built-in system that prevents the motors from starting if the radio transmitter is turned on with the throttle value above its lowest point. For example, I have disabled it for myself. Custom position. When this option is selected, a numerical field appears that can be configured to check the throttle state against a user-defined value, from -100 to 100. This is useful for those whose throttle stick has a non-standard value or due to technical issues, in order to pass the assistance check and be able to start the motors. For example, the radio might only allow the motors to start at a value of -70. Switch warning is used to check the positions of all configured switches when the radio is turned on. This warning helps ensure that all switches are in the correct position for safe startup and operation of the model. Here, the switches and their required positions are indicated for you to be allowed into the main menu. Most flight controllers already have a built-in system that prevents the motors from starting if the radio is turned on with the armed switch in the armed position. I have disabled this check for myself. POTS warning is used to check the positions of all configured potentiometers and sliders when the radio is turned on. This warning helps ensure that all POTS and sliders are in the correct position for safe startup and operation of the model. There are 3 options: off, on, and auto. When on or auto is selected from the drop-down menu, buttons for the available POTS and sliders appear. The positions of POTS and sliders are not checked. The positions are checked against the manually configured positions of the POTS and sliders that are set as active. The positions are checked for activated POTS and sliders and are compared to the last automatically saved position before the radio was turned off or the model was changed. I do not use this setting. Center beep allows you to enable or disable the center beep function for individual sticks, potentiometers, and sliders by selecting them. This is useful for identifying the center position of the control elements during flight or setup. RETA is an abbreviation that stands for the main control channels, commonly used in radio-controlled airplane modeling and other models. Here's what each letter means. Rudder used to control direction in our case, W. Elevator used to control altitude up or down in our case, pitch. Throttle used to control the speed or power of the motor. Aileron used to control roll or bank left or right, in our case, roll. If you highlight these letters, your radio will now vibrate and beep when the sticks are in the center. It's a rather specific function, but someone might find it useful. The ADC filter analog to digital filter is used to process signals before they are converted by the analog to digital converters ADC. It's a crucial element for improving signal quality and reducing noise. The ADC filter is designed for proportional channel sticks, potentiometers, sliders, and smooths out small, fast movements caused by electronic noise in the system. Until Betaflight version 3.5, it was a useful function for drones and planes without a flight controller. For models with flight controllers, this filter is usually turned off, as flight controllers handle analog signal processing themselves. Internal RF. The internal radio module setting is responsible for configuring the built-in radio communication module within the radio transmitter itself. When the off parameter is selected in the settings for the internal or external RF module, it means that the radio module is not being used. In other words, the radio link through this module is inactive for the selected model. This can be useful when you want to use the model without an active radio link, for instance, when flying on a simulator or when you are using a different module for control, such as an external one. This will save battery life and allow you to remove the antenna from the radio transmitter so it doesn't get in the way. The external RF and internal RF modules cannot operate simultaneously. Mode selects the radio communication mode. On my radio transmitter, I have an ELRS transmitter module, and it operates under the name CRSF. I cannot select anything else here. But if your radio transmitter operates on a 4-in-1 or CC2500 protocol, you will be able to select the necessary communication protocol that your drone's receiver uses. CRSF 1.87m or baud rate. The data transfer speed between the transmitter module and the radio transmitter. This means that the Crossfire serial frame protocol operates at a data transfer speed of 1.87 megabits per second Mbps. This is one of the data transfer modes that provides high speed and low latency, which is crucial for precise and fast control of models using the ELRS protocol. Status displays the packet rate settings of the transmitter module. I have it set to 1000 Hz, which I would say is a very high packet update rate that allows for fast data reception at the receiver. It's very useful for hardcore freestylers and those who are into racing. At 50 Hz, you can fly very far, but with some latency. We will talk about this in more detail in another video. Channel range. The channels that will be used for communication. In the CRSF settings, the channel range parameter allows you to define which channels will be used for communication between the transmitter and receiver. If the value is set to CH1 to 16, it means that channels 1 through 16 will be active and used for signal transmission. This range includes the first 16 communication channels that can be configured for various functions, such as controlling motors, ailerons, elevator, rudder, and other auxiliary functions. You can configure each channel separately according to your needs, assigning them appropriate functions and values. But I recommend leaving it as is. Receiver number. This is a user-assigned number for a specific model, which is transmitted to the receiver during the binding process. This number helps to identify the model and avoid conflicts between different models that use the same transmitter. If you accidentally turn on two models at the same time, assigning a unique number to each receiver helps avoid potential conflicts and erroneous commands. Personally, I never turn on two drones at the same time, so this function is a bit strange to me. External RF. External radio module is used to configure an additional radio module that is installed in the external bay of the radio transmitter. This module allows you to expand the capabilities of your radio control system. For example, if your radio transmitter operates on the ELRS protocol, but your drone's receiver uses the CRSF protocol. Thanks to a changeable module with the CRSF protocol, you'll be able to fly the drone. It has the same settings as the internal RF. Mode selects the radio communication mode. For it to work, you need to change the value from off to the protocol your external module uses. On my radio transmitter, I have a module on the CRSF protocol, so I select it from the list. There are many others here, but in most cases, people use modules with ELRS and CRSF protocols, both of which use the abbreviation CRSF for their operation. In my case, let's consider an external module on the CRSF protocol. The maximum baud rate for CRSF that it can support is 400K. If you set it higher, the receiver on the drone will immediately unbind. A lower value is acceptable. The channel range and receiver number lines have the same meanings as in the internal RF settings. Training mode is used for training new pilots or for jointly controlling a model with two operators. An experienced pilot instructor can help a novice student control the model. The instructor has the ability to quickly take over control if necessary. This ensures safe and effective training for new pilots. Master mode. This is the mode for the radio transmitter that will be connected to the model. Slave mode. This is the mode for the radio transmitter that will transmit its CPPM values to the master mode radio, which are then passed on to the model. Trainer mode is not used for this model. Master mode using a cable connection. Slave mode using a cable connection. Channel range. This is the range of channels that will be transmitted to the master radio. It is recommended to use channel 10 as the last channel. PPM frame. The first field is the PPM frame length. The second field is the stop duration delay between pulses. The drop-down list allows you to select the signal polarity. The frame length is automatically adjusted to the correct value when the number of transmitted channels changes. However, this automatically assigned value can be changed manually. In most cases, the default settings do not need to be changed. Now let's try to put two radio transmitters into training mode in practice. To do this, on one radio, we select Master Jack. This will be the instructor's radio. On the other radio, we select Slave Jack. This will be the student's radio. Now we need to connect these two radios with a 3.5mm mini jack cable into the trainer port on the radio itself, and don't confuse it with the audio output for headphones. Now, on the instructor's radio, we need to assign a switch that will activate this mode. To do this, on the instructor's radio, press the model button. Navigate to page 10, titled Special Functions. Select any free switch. For me, it's SB, and let's have it be the down position. In the down position, the student will control the drone. When I flip the switch to the up position, control fully transfers to the instructor. Next, select Trainer from the list, then select Chans from the list. And at the end, check the box. That's it. Now we can check if everything is working. On the instructor's radio, set the selected switch to the down position. Go to the main screen. Press Page to go to the channel monitor screen, and we can see the students' inputs. Thanks to this trainer mode, you can safely teach your students and not worry about them crashing a drone or plane in a critical situation. Let's move on to the next section, flight modes. Flight modes allow you to have different trim settings for each flight mode. Once you have configured several flight modes, you can change the trim settings in each flight mode without affecting the trims of other modes unless they are configured to do so. There are 9 possible flight modes, with flight mode 0 being the default. In the context of FPV drones and pilots who fly with goggles, working with trims is, to put it mildly, quite a quest, and we set these flight modes using switches, not trims. This is more useful for airplanes. Let me tell you a bit about what might be interesting here for a drone. For example, I have completely removed the trims because sometimes you accidentally move them back and forth and then wonder why the drone is pulling to one side. Most pilots disable them entirely. Let's do that. Select channel FM 0, then the trims line instead of zeros, we put a dash. That's it, now the trims won't bother us and we won't accidentally touch them. The main thing is to set them to the center position on all axes before disabling them in this menu. For those who can't live without them, there is an option to enable and disable them with a switch. There is nothing else of interest for our drone here. Let's move on to the next page, Inputs. In this menu, we assign all our physical switches, buttons, and sliders that you have on the radio transmitter itself. This allows you to precisely configure how each physical control element will interact with your model. To support many different types of radio transmitters, EdgeTX uses a common data control flow that can be applied to any radio. In this data flow, any physical control elements of the radio joysticks, switches, sliders, potentiometers can be assigned as an input in the software. These inputs can be directly assigned or combined with other inputs into a single mixer. These mixers can be modified by applying offsets and curves, and then assigned to a channel for output. The final control data adjustments are made including curves, endpoints, and center values before the control data is sent to the radio module. Some pilots believe that configuring inputs is not a necessary step, as they can directly configure all the necessary parameters on the Mixes tab. This can simplify and speed up the setup process. In many cases, EdgeTX automatically assigns the main physical control elements joysticks to the main channel's aileron roll, elevator pitch, throttle, rudder wobble. This is why in the Betaflight software you see TR1234 or ETR1234. The numbers represent the number of primary control channels for arm-disarm, fly mode. Some pilots may not feel the need to configure inputs manually because the standard settings already suit their needs. Skipping the inputs setup can limit the ability to fine-tune the behavior of the inputs. Without setting up inputs, you cannot apply offset modifiers or curves to the inputs, which can reduce control precision. Overall, the choice of setup method depends on the individual needs and experience of the pilot. Both approaches have their pros and cons. Let's figure out how everything works here. We can see that 4 channels are occupied by the control sticks. Let's add all our sticks, switches, and buttons here. It's very simple. We need to assign them to the free channels. To do this, I select channel 5. The input configuration page allows you to edit the input configuration parameters. To the right of the configuration parameters, you can see a live graph that shows how your configuration parameters will affect the input slope. Input name, the name for the input. Up to 4 characters can be used. I very rarely write anything here, the physical control element used for the input. After selecting the source, moving the physical control element will automatically assign it to this input. This speeds up the setup. The percentage value of the stick movement that is used often called rates. Rates allow you to adjust the sensitivity of the stick. For example, if you decrease the rates, your stick will become less sensitive, which can be useful for smooth and precise control of the model, especially when flying at high speeds or performing complex maneuvers. Let's take aileron as an example, and I'll reduce the value to 30%. If we now look at the pulse length on the main screen, we can see how it works in both directions on roll at only 30%. The same can be done in the Betaflight settings. But in field conditions, changing these settings from the radio transmitter will be easier. You can set different rate values for different flight modes or conditions. For example, you can have high rates for acrobatic flying and low rates for stable cruising. Every pilot has their own preferences for control sensitivity. Using rates, you can adjust the model to your personal needs and flying style. A value added to or subtracted from the input source. If your physical control element, for example, a joystick is not centered in its neutral position, you can use offset to correct this displacement to ensure the model responds correctly in the neutral position. Your control elements may have a natural offset that needs to be corrected for precise control. Offset makes it easy to perform this correction. Curve determines the type of curve that will be used. The following curve options are available. Exponential curve is used to adjust the sensitivity of the stick control to achieve smoother and more predictable model control. Increasing the percent will result in a gentle slope near the center zero. Decreasing the percent will result in a steep slope near the center zero. With the percent equal to 0, the slope will be linear. Expo allows you to reduce the stick's sensitivity near its center position. This makes the model less responsive to small stick movements, which can help avoid accidental or excessive movements. Reducing sensitivity near the center of the stick helps the pilot make more precise corrections, especially during flights that require high precision, such as navigating through narrow spaces or during landing. Although sensitivity near the center is reduced, Expo allows you to maintain high sensitivity at the edges of the stick's travel. This means that with large stick movements, the model responds quickly and energetically. As the Expo percentage increases, the sensitivity curve becomes flatter near the center, which reduces the stick's sensitivity in this range. As the Expo percentage decreases, the curve becomes steeper near the center, which increases the stick's sensitivity in this range. At a value of 0%, the sensitivity curve is linear, which means uniform sensitivity throughout the entire range of stick movement. Diff multiplies only the range above or below the center zero by the specified percent. Suppose you want the model to be more sensitive to stick movements in the positive range and less sensitive in the negative range. You can configure diff to multiply the positive range by a larger percentage and the negative range by a smaller one. It allows you to adjust the stick's sensitivity separately for different ranges of motion, ensuring precise control over the model. Functions a very strange curve setting that has its own combinations. I can't even say how this could be used for a drone. Custom. You can create and customize individual curves for inputs, which allow for more precise control over the model's sensitivity and behavior. The mode setting allows you to define for which flight modes this input will be active. This means you can configure a specific input to work only in certain flight modes, while being inactive in others. The switch that activates the input line. If no switches are defined, it is always active. Using any other switch, you can activate or deactivate the rates mode. This can even be done during flight. If you select the dash, the setting will be valid for the entire range of the source's values. If you select x greater than 0, the setting will be valid for the upper half of the source's values. If you select x less than 0, the setting will be valid for the lower half of the source's values. Trim indicates whether to include the trim values in this input. This allows you to configure how your trims will affect the model's behavior. And so, let's map out all our buttons, switches, and sliders to the channels. For convenience, I do this in order, starting with the switches, then the buttons, and finally the sliders. Select source and press the first switch. For me, it's a SIT. The radio will automatically populate this channel and its name. Done. Exit and move to channel 6. Again, select source and choose the next switch, SB. By the way, on my radio, the switches are in alphabetical order. SA, SB, SC, SD for convenience, I will add them to the input channels in that order. Next, I move on to the radio's buttons. Then I move on to the sliders. All done, I have created 12 channels for my radio transmitter. Let's move on to the mixes page. For all the channels to work, it is essential to activate the channels in this menu that were added on the previous inputs page in the exact same order. If you don't do this and don't configure the channels, all other channels besides the main controls will not work. The mixes screen in the model settings is used to combine several inputs into a single channel mix. These mixes are then assigned to a radio channel for output. Similar to the input section, you can assign a weight, offset, or curve to the channel mix. This allows for precise tuning of the mixer's behavior. We start by mapping our switch channels in the same order as on the previous inputs page. If you've already done it there, here you just need to go into the channel and it will automatically pull the selected switch or button from the previous inputs page. If you haven't done anything on the inputs page, then you start doing it manually in the same order. To check the result of the channel setup, go to the main screen and use the page key to navigate to the mixer's monitor page and verify that all channels are working correctly. Now let's take a closer look at the mixes page. It is very similar to the inputs page but with some differences. A name for the mixer optional. Up to 6 characters can be used. The physical control element used for the input. After selecting the source, moving the physical control element will automatically assign it to this input. The percentage value of the stick movement that is used, often called rates. Rates allow you to adjust the sensitivity of the stick. A value added to or subtracted from the input source. If your physical control element, for example, a joystick is not centered in its neutral position, you can use offset to correct this displacement to ensure the model responds correctly in the neutral position. Your control elements may have a natural offset that needs to be corrected for precise control. Offset makes it easy to perform this correction. This parameter determines whether to include the trim values in this mixer. For the trim values to be included, the trim field for the corresponding input must also be activated on the inputs page. We have already discussed curve, mode, and switch on the inputs page. Next are some very specific settings that, in my opinion, are difficult to use in the context of FPV drone flying. Warning: when this parameter is selected, the radio transmitter will beep when the mixer is active. You can choose OFF0 or beep patterns 1, 2, 3. The multiplex parameter determines how the current mixer line interacts with others on the same channel. Adds its output to the other mixers on this channel. Multiply. Multiplies the result of the mixers above it. Replace. Replaces everything that was done before with its own output. Delay up. Creates a time delay in seconds between an increase in the source value and its output. Delay down. Creates a time delay in seconds between a decrease in the source value and its output. Slow precision. Changes the precision for slow up or down between 0.0 and 0.00. Slow up adjusts the transition speed for an increasing source value. Specify the time for the transition from -100% to +100% in seconds. You can specify a range from 0 seconds to 25.00 seconds. Slow down adjusts the transition speed for a decreasing source value. Specify the time for the transition from -100% to +100% in seconds. You can specify a range from 0 seconds to 25.0 seconds. Let's move on to the next page, Outputs. The output screen in the model settings is used for the final configuration of the control data, including subtrims, curves, endpoints, and center values before the control data is sent to the radio transmitter. This is where the channel center, limits to prevent servos from binding, and output direction are set. All these channels also follow the pulse order that we first chose on the inputs page, then mixes, and here we do the final adjustments. Very rarely does anyone change anything here, but let's see what can be done. For example, let's take the first channel. It is responsible for roll. A name for the output. Up to 6 characters can be used. Subtrim. The subtrim value maximum 100. Used for fine-tuning the neutral position of a servo or other control element. This allows for small corrections to ensure the correct center position of the output without needing to physically adjust the control element. Minim. The minimum output value. Typically used to prevent servos from binding on models that use servos to control surfaces. Maximum. The maximum output value. Also typically used to prevent servos from binding on models that use servos to control surfaces. Direction. Inverted. Select this option if you want to invert the output value. Curve. Specify a custom curve, if any, that you want to use for this output. PPM center. Specify the pulse width value for the center value of the output channel from 1000 to 2000. Changing this value will shift the entire output range, including the upper and lower limits. Subtrim mode. Defines how the subtrim value will affect the minimum or maximum output values. There are 2 options. Center only. Only the center value is shifted, the upper and lower limits do not change. The stick response will be different between the upper and lower halves from the midpoint. Symmetrical. The upper and lower limits will be shifted according to the offset of the center value. The stick response is the same on both sides of the midpoint. And in this way, we can configure any active channel of the radio transmitter to our needs. Let's move on to the next page, Curves. Control value or control variable. This value is used to define a point on the curve that corresponds to a specific input value. In other words, it is a control point that helps determine how input signals are converted into outputs according to the configured curve. The curve screen in the model settings allows you to define custom curves for use on the Inputs, Mixes, or Outputs tabs. The curve screen will show all configured custom curves with a graphical representation of each curve, the number of points, and the curve type. The screen shows a graphical representation of each curve, allowing you to see how your settings affect the output. You can specify the number of points used to define the curve. More points allow for creating more complex and precise curves. You can choose the type of curve to be used, for example, linear, exponential. This helps to tailor the model to your needs. For example, suppose you are setting up the stick for aileron control roll and want to make it less sensitive near the center position to avoid accidental movements. You can create an exponential curve that will provide this behavior. Let's move on to the next page, Special Functions. This section provides additional functionality that allows for more detailed model configuration. These functions can include enabling trainer mode, playing sounds, adjusting the radio's backlight, adjusting the volume, and many other possibilities. Let's create a new function. Click on the dashes. For example, I want to activate something with the SB switch in the down position. Override. Overrides the value of a specified channel with a set value. Next is the channel to override. Value the value to replace the normal channel value range from -100 to +100. It's actually hard to come up with something interesting for this function for our drone. Trainer. Enables trainer mode. Value defines which control elements will be passed to the student. Options sticks all sticks, rudder, elevator, throttle, aileron, chans all channels. The main thing is not to forget to check the box to activate the new function after creating it. The instant trim function allows you to quickly and easily adjust the trims on your transmitter. This function automatically sets all trims to the current values of their corresponding sticks. This is very useful when you want to quickly trim a model for stable flight or when you find that your sticks are slightly off-center and you want to save the current position. For our FPV drone, this function is not needed. Reset timer. Reset resets a timer or telemetry to its initial values. Options timer 1, timer 2, timer 3, flight, telemetry, sets a specified timer to a set value. Parameters timer 1, timer 2, timer 3. A strange setting, but it exists. Adjust the ability to change the value of global variables in real time to adapt to flight conditions. This specific parameter currently requires separate testing for FPV drones. It is used by a very limited circle of pilots for their very specific tasks. Volume changes the volume of the radio transmitter. To do this, select the on mode, and I want to assign volume control to a slider. Done. Sets the fail-safe values for the selected module internal or external to the current stick positions upon activation. This function is useful when you don't have the ability to set up fail-safe through Betaflight. This way, you can assign this function here. Play sound plays the sound selected in the value field upon activation. Value the sound to play. There are various sounds. Repeat the frequency of sound repetition. Useful for those who want to hear when a switch responds to commands. By the way, a useful thing when activating fail-safe mode via a switch is to hear commands that you are currently activated for automatic return to home. Playtrack plays the library sound file selected in the value field upon activation. Repeat the frequency of track repetition. A useful thing for those who forget which switch is responsible for what. Let's assign them. The SA switch is for activating the buzzer. I'm looking for the voice Buzact in the library. We copy the first function and change the position to up. Check the box. Now we look for buzz off. Moving on. The SB switch is responsible for my flight modes. I choose the up position for acro mode. The middle position is horizon mode. The down position is angle mode. The right switch SD is for arm and disarm. In this simple way, you can assign any commands you need to be announced. Play value announces the value of the selected element in the value field.
Buzzer active, buzzer off. Horizon mode, angle mode, acro mode.
Value the source of the value to be announced. Repeat the frequency of the announcement repetition. A specific function, Lua script, executes the Lua script defined in the value field. Value the Lua script to execute from the SD card. Repeat the frequency of script execution. Lua scripts allow you to add new functions that may not be available in the standard set of EdgeTX functions. We will talk about them in detail in future videos. BG Music plays a wave file in a loop upon activation. Value the wave sound file to play from the SD card. For music lovers, there is an option to activate a specific track on a switch and listen, for example, to a Rammstein track when the ARM switch is activated. G-Music 2 temporarily pauses the playback of the wave file specified in BG Music. Enables the variometer sound for the model's ascent and descent. For this function to work, the barometer in the drone needs to be working. Haptic. This function is for fans of vibrating radios. It's hard to say what it's for. It causes the radio to vibrate upon activation. Value the type of vibration pattern. Options 0 or 4. Repeat the frequency of vibration repetition. SD logs. Creates a CSV file with radio and telemetry logs on the SD card. Value the log recording interval 0.1s to 25.5s. You can save detailed flight data such as altitude, speed, position, battery level, etc. This allows you to analyze flights and determine how your model performs in different conditions. Data logs can help identify the causes of malfunctions or crashes. You can review the logs to find anomalies or problems with telemetry and model parameters. Analyzing data logs allows you to optimize your model settings. You can see how parameters change during flight and make adjustments to improve performance. Backlight adjusts the brightness of the radio transmitter's screen. Screenshot creates a screenshot as a BMP file on the SD card. Racing mode enables racing mode low latency for FR Sky Archer receivers. Audio amp off turns off the audio amplifier to mute the speaker, including extraneous noise. Let's move on to the next page, telemetry. Telemetry is data received from the model to the radio transmitter from various sensors. These sensors can be built into the drone's receiver or flight controller, or they can be separate sensors such as a GPS, variometer, or magnetometer. The received telemetry data can be displayed by EdgeTX as widgets, configured as alarms, or as audible notifications. Sensors. All previously configured sensors are displayed here. In this window, you can see all the available sensors that the flight controller can provide. In my case, it reads 18 sensors. When a sensor receives a data update, a small circular icon will appear to the left of its value. Here you can see how much battery capacity has been used, the battery charge percentage, the quality of the connection between the transmitter and receiver, etc. When selected, a search for new sensors on the model is performed with automatic configuration. When selected, a new empty sensor is created that needs to be configured manually. This option will delete all previously configured sensors. Note this button will be invisible if no sensors are configured. The value RXBT stands for Receiver Battery Telemetry. This means the sensor displays the status of the receiver's battery, which can be important for monitoring its condition during the model's flight. The value curve displays the current amperage being consumed by the model. Measuring current can be important for monitoring the performance and energy efficiency of your model during flight. The value kappa indicates the battery capacity. This telemetry value displays the amount of charge remaining in the battery and is usually measured in milliampere-hours mAh. Monitoring battery capacity is important for ensuring flight safety and preventing unexpected power loss. The value BAT percent indicates the battery charge percentage. This telemetry value displays the percentage of charge remaining in the battery. Monitoring the battery charge percentage allows for better flight planning and ensures timely recharging to avoid unexpected power shutdowns. The value 1 RSS indicates the first received signal strength indicator RSSI. RSSI is a measurement of the signal strength being received by your receiver from the transmitter. It is an important parameter for assessing the quality of the link between the model and the radio transmitter. The value 2 RSS indicates the second received signal strength indicator RSSI. This is another parameter that measures the signal strength received by your receiver from the transmitter. It is useful for models with dual receivers or antennas, where two different signal strength values can be compared to assess the link quality. The value RQY indicates the receive quality. This telemetry value displays the percentage of quality data packets received by the receiver from the transmitter. High signal quality means that most data packets are transmitted successfully, while low signal quality may indicate potential communication problems. The value RTA receive signal to noise ratio indicates the signal to noise ratio of the received signal. This telemetry value reflects the quality of the received signal relative to the noise level. A high SNR value means the signal is clear and less noisy, while a low SNR value indicates possible issues with interference and link quality. The value ANT may indicate the antenna status. This could be a telemetry value showing whether your receiver's antennas are functioning correctly. High signal quality and a reliable link between the model and the remote can depend on the proper functioning of the antenna. The value RFMD RF mode indicates the radio frequency communication mode. This telemetry value shows which mode the transmitter or receiver is operating in. Different modes can affect the communication range, signal stability, and power consumption. The value TPW or transmit power indicates the transmitter's power. This telemetry value shows the current power at which the transmitter is transmitting the signal. The importance of this parameter is that higher power can increase the communication range but may also lead to higher energy consumption. The value TRSS transmit received signal strength indicates the signal strength transmitted by the receiver. This telemetry value shows the strength of the signal that the receiver gets from the transmitter and is important for assessing the quality of the link between the model and the remote control. The value transmit quality indicates the quality of the transmitted signal. This telemetry value shows the percentage of successfully transmitted data packets from the transmitter to the receiver. High transmit quality indicates a stable and reliable connection, while low quality may indicate possible data transmission issues. The value transmit signal to noise ratio indicates the signal to noise ratio of the transmitted signal. This telemetry value reflects the quality of the transmitted signal relative to the noise level. A high SNR value means the signal is clear and less noisy, while a low SNR value indicates possible issues with interference and link quality. The value FM may indicate the frequency mode. This telemetry value shows which frequency range the transmitter or receiver is operating in. The frequency mode can affect the communication range and signal stability. Here you can configure the thresholds for receiver alarms. Low alarm. The threshold value at which the voice message RF signal low will be played. The recommended value is 45. Critical alarm. The threshold value at which the voice message RF signal critical will be played. The recommended value is 42. Disable telemetry alarms. If enabled, the alarm voice messages will not be played. A variometer detects changes in the model's altitude. EdgeTX can notify the user of these altitude changes by providing sounds with increasing or decreasing pitch. Use the variometer menu on the radio setup page to set the actual frequency and volume of the sound that will be played. The following options are available for configuring the variometer alarm. You will need to use the special vario function or a global function to enable this functionality. Specifies the sensor that will be used as the variometer. It is selected from the telemetry sensors added in the Sensors section. Defines the climb or descent range that will trigger a change in the variometer's signal pitch. If the climb or descent rate is within the range specified here, the signal pitch will change accordingly. When it goes beyond the specified range, the signal pitch stops changing. The units are meters second or feet second depending on the unit settings on the radio setup page. Sender. Defines the range for ignoring changes in the climb-descent rate. When the climb-descent rate is within the range specified here, the signal pitch will not change. Tone silent indicates whether to play a signal when the climb-descent rate is within the range specified by the center. Let's move to the display section. The display page provides the ability to customize the telemetry screens that are displayed when you press the telemetry button on the main screen. You can configure up to 4 telemetry screens and choose one of the following display types for each screen. Nums. Numbers. This display type shows the numerical value of a selected telemetry sensor or other configured object. The screen will be divided into 2 columns with 4 rows. Each cell can display data from different sensors or objects. On the display screen, the top bar will show the model name, radio transmitter battery voltage, and time. Bars. This display type shows a bar graph representing the value of a selected telemetry sensor or other configured object. The screen will be divided into 4 rows. Each row can display data from different sensors or objects. For each sensor, you need to define the minimum and maximum values for the bars. On the display screen, the top bar will show the model name, radio transmitter battery voltage, and time, in addition to the configured cells. Additionally, the bottom bar will show a 5th bar with the RSSI value. Script. This type executes a configured telemetry Lua script. The telemetry Lua script must be located in the folder on the SD card, scripts, telemetry to be available for configuration. These parameters allow you to customize the display of telemetry information according to your needs. Congratulations, we have finished the large menu accessed with the model button. Let's return to the main screen and press the system key. It starts with the Tools page. On the Tools page, you can select script-based tools to execute. Lua scripts located in the Tools folder on the SD card will be displayed here. Selecting a tool will run it. By default, EdgeTX includes several tools. Other tools can be downloaded and added to the SD card. In our case, we are interested in working with the popular radio communication protocols, Express ELRS and CRSF. Today, we will talk about the Express ELRS protocol. Packet rate is the update frequency of data packets between the radio transmitter and the receiver. The update rate for the receiver in an FPV drone determines the speed at which it processes the data received from the transmitter. This frequency is measured in hertz and shows how many times per second the receiver can receive and process new commands or data. A high update rate provides a faster response from the drone to the pilot's commands. For example, at an update rate of 100 Hz, the receiver gets updates 100 times per second. This allows for smoother and more precise commands without delay, ensuring more stable and accurate control over the drone. Although not everyone may feel the difference, it matters during races or when performing complex maneuvers. 500 Hz. A very high update rate that provides an instant response to commands, ideal for racing. However, it has a shorter range. 100 Hz. Popular for many FPV systems, providing a good balance between precision and power consumption. 50 Hz and below. Can be used for less critical tasks, but a certain delay in the drone's response will be noticeable. It has a longer range. Higher update rates can consume more energy but provide faster and more stable control. Next to it, we see the value -115 dBm, which defines the RSSI sensitivity limit. This value is displayed on the OSD in the goggles. It is the lowest theoretical RSSI value that the radio receiver can distinguish. It is displayed next to the packet rate in the ELRS Lua script, as different packet rates and frequency bands have different sensitivity limits. Lower frequencies are more sensitive, from -123 dBm for 25 Hz at 915 MHz to -105 dBm for 500 Hz at 2400 MHz. This gives you a limit below which you cannot fly. In other words, the shorter the wavelength, for example, 2.4 GHz, the higher the packet rate you can get, but with less range, and conversely, with a longer wave, you can get a greater range but fewer data update packets. If you are flying long distances, it is advisable to use a longer wave, for example, 900 MHz, and the lowest update frequency, for example, 50 Hz. If it's important for you to get the most responsive drone and you fly at close range, it's better to choose 2.4 GHz and the highest update frequency supported by your radio transmitter. Here is an example table where you can see the data packet speed, transmission duration, and transmission interval. D500. This means the packet rate is 500 Hz dynamically adjusted. This means packets are transmitted 500 times per second, ensuring high precision and fast data transfer. F500. This means the packet rate is 500 Hz fixed. This means the packet rate remains constant at 500 Hz. 500. This simply denotes a packet rate of 500 Hz without additional specifics. 333 Hz. Full means the data packet transmission rate is 333 Hz. Data is transmitted between the transmitter and receiver 333 times per second. The word full means that the system uses all available capabilities and resources to ensure the most stable and fast connection. This setting provides a high reaction speed to the pilot's commands, which is especially useful for FPV drones during races or when performing complex maneuvers. Telemetry ratio is an important parameter that determines the ratio between transmitted control packets and telemetry packets. This ratio determines how often telemetry packets are sent back to the radio transmitter, which is critical for receiving important information about the drone's status. How telem ratio works. Control packets. These are data packets sent from the radio transmitter to the receiver on the drone. They contain the pilot's commands, such as stick movements, flight mode commands, etc. Telemetry packets. These are data packets sent from the receiver on the drone to the remote control. They contain information about the drone's status, for example, battery level, RSSI, GPS coordinates, and other telemetry data. Example telem ratio settings. 1:1. Every control packet is accompanied by a telemetry packet. This provides the highest level of feedback but can increase the load on the system. 1:2. For every 2 control packets, 1 telemetry packet is transmitted. This reduces the system load while maintaining a sufficiently high level of telemetry feedback. 1:4. For every 4 control packets, 1 telemetry packet is transmitted. This can be useful for reducing the system load while retaining basic telemetry. Choosing the optimal telem ratio. At long distances, it may be useful to reduce the frequency of telemetry packets to ensure a stable connection. For high-precision telemetry data requirements, for example, during races, it may be appropriate to use a ratio of 1:1 or 1:2. In high-interference environments, it may be useful to reduce the frequency of telemetry packets to avoid overloading the system. Choosing the right telem ratio allows you to optimize the performance of the ExpressRS system and ensure a stable and reliable link between the radio transmitter and the drone. A ratio of 1:128 means that for every 128 control packets transmitted from the remote control to the receiver, 1 telemetry packet is transmitted. Using a low ratio of telemetry packets helps to reduce the load on the radio channel, which allows for more bandwidth to be preserved for control packets. A low frequency of telemetry packet transmission helps maintain a stable connection over a greater distance, which is important for long-range flights. Switch mode. Channels 1 to 4 are the control channels roll, pitch, throttle, and yaw, and they always have the full 10-bit resolution. But for the remaining channels AUX1 to AUX8, which are typically used for switches, their resolution depends on your requirements. The switch mode setting controls how the AUX1 to AUX8 channels 5 to 12 are transmitted to the receiver. There are 2 options, hybrid and wide. In hybrid mode, the AUX channels will only be 2 or 3 position, which is ideal for reducing latency. In wide mode, your channels will have 64 or 128 positions, which provides enough resolution for most things we want to do. For FPV drones, I usually recommend using wide mode. Model match. This function provides an additional layer of safety and precision when controlling different models of drones or other RC devices. The main idea of model match is that each radio transmitter can be paired with a specific model and only with that model. Each model has a unique identifier that is stored in the radio's memory. The radio transmits this identifier with every signal, and only the model with the corresponding identifier responds to these commands. This prevents accidental control of other models, which can happen if you accidentally select the wrong model on your radio. To use model match in ExpressRS, go to the model settings on your radio transmitter, scroll down to internal RF or external RF if you are using an external ELRS module. In the receiver RX options, set a unique model identifier any number from 0 to 63. In this example, I will use 2. All done. Transmitter power TX power. Available options are 25 milliwatts, 50 milliwatts, 100 milliwatts, 250 milliwatts, 500 milliwatts, and 1 watts. Note that with the EU LBT firmware, the RF power is limited to 100 milliwatts. Some modules support up to 250 milliwatts, while others are capable of operating up to 1 watts. Tests have shown that even 2.4 GHz at 100 milliwatts can achieve a range of 33 kilometers, which can easily surpass most 5.8 GHz video transmitters, so it's not always necessary to use the highest available power. Higher power consumption can significantly reduce the battery life of the radio transmitter and increase the risk of overheating without proper cooling. At RF power levels above 250 milliwatts, it is recommended to enable the fan by setting the fan threshold to 250 milliwatts. Enabling the dynamic power option allows the system to automatically adjust the output power based on signal strength. Dynamic power uses SNR signal to noise ratio instead of RSSI to determine the power level, as RSSI does not account for the noise floor or the presence of an amplifier in the receiver. This can potentially save battery life by reducing power when the receiver is nearby and increasing power only when necessary. If dynamic power is enabled, the max power setting will be the upper limit. The appropriate power level for your FPV drone depends on your desired packet rate and range. Using Express ELRS at 50 Hz can provide extraordinary range, even at 100 milliwatts. However, if you plan to use a higher packet rate, such as 500 Hz, your range will be significantly reduced, and you may need more output power to maintain the same distance. 250 milliwatts should be sufficient for most people flying a few kilometers away, even at 500 Hz, but of course, higher power will provide better signal penetration, not just range. Regardless of the power, if you want the most reliable link or to fly long distances, it is generally recommended to stick to a lower packet rate, such as 50 Hz, as it provides higher signal sensitivity. Fan threshold fan thresh is a setting in radio modules that determines at which transmitter power TX power the cooling fan will turn on. This helps prevent the module from overheating when operating at high power. Setting the fan thresh means the fan will turn on automatically when the transmitter power exceeds a certain level. For example, if the threshold is set to 250 milliwatts, the fan will turn on when the transmitter power reaches or exceeds 250 milliwatts. VTX Administrator is a feature in ExpressRS that allows you to control your video transmitter directly from your radio. This is very useful because you can change the VTX band, channel, and power without needing to change the settings on the drone itself. To use this feature, you need to configure Smart Audio, Tramp, or MSP on your flight controller. Wi-Fi connectivity allows you to manage your devices via a wireless connection. This can be useful for configuration, firmware updates, and for communicating with other devices such as a VRX video receiver, ground station, etc. A major lesson on flashing internal and external modules using this function will be in future videos. TX Backpack is an additional feature in the Express ELRS ecosystem. It allows you to wirelessly control FPV devices directly from your radio transmitter. For example, you can conveniently change the channel on your analog FPV goggles using your radio. To use the TX Backpack, both the Express ELRS transmitter and the device you want to control must be equipped with an ESP8285 chip. BLE joystick. Bluetooth Low Energy Joystick is a wireless game controller that uses Bluetooth technology to connect to devices such as smartphones, tablets, PCs, and game consoles. To use it, you need to have Bluetooth in your radio transmitter. Express ELRS is the process of connecting your radio transmitter TX with a receiver RX to create a wireless link. This allows you to control your devices directly from the radio. We will discuss the methods and nuances in more detail in future videos. Below is the version of the ELRS protocol. Let's move to the next page, SD card. Here, the contents of your SD card are shown, allowing you to navigate through folders and interact with the files within them. All folders contain a readme.txt file that describes what types of files belong in that folder. The folders you see on the SD card screen are the same as those you will see when you connect your radio transmitter to a computer. The backup folder contains model files for models that have been saved from the EEPROM. This folder will only be present on radio transmitters that store model files in EEPROM. The EEPROM folder on the radio is used to store model settings and configurations in the internal EEPROM memory. This allows the radio to save and restore different settings for each model you use. Firmware. Place firmware files that you want to flash in this folder. This folder is empty by default except for the readme.txt file. When you select a bin file, you will be prompted with an option to flash the firmware to a specific module. Also, only firmware files in this location will be visible from the bootloader menu. Logs. Log files that are configured in the SD logs special function are stored here. These files can be viewed using the View Text option. This folder is empty by default except for the readme.txt file. Model files and pre-flight checklists are stored here. Each model will have a model YML file that contains all its configured options. Radio. This folder contains the radio.yml file. This file contains all the radio transmitter's configuration data. If this file is corrupted or missing, the radio will enter failsafe mode and create a new radio YML file with default settings. Screenshots. Screenshot image files that are configured in the screenshot special function are stored here. This folder is empty by default except for the readme.txt file. Scripts. This folder and its subfolders are for placing Lua scripts. It contains the following default subfolders. You can download additional Lua scripts from this website. This folder contains the EdgeTX sound packs for your radio transmitter. Sound packs are language dependent and correlate with the voice language option in the radio settings. Selecting a sound file from this folder will give you the option to play the selected sound file. Let's move on to the next page, Radio Setup. This is where you can configure the basic parameters of your radio transmitter. It includes the following options. Bat range sets the maximum and minimum voltage for the battery indicator. This should be configured according to the type of battery you are using. Sound mode configures when sounds are played. Beeps when buttons are pressed and plays sounds for notifications or warnings. No beeps when pressing buttons or scrolling the wheel, but plays sounds for notifications or warnings. Sounds triggered by special functions are also played. Only plays sounds for alarms or warnings. Sounds triggered by special functions are also played. No beeps or sounds. Volume. Overall volume of the radio transmitter. Beep volume. Volume of the beeps. Duration of the beeps. Beep pitch. Pitch of the beeps. Wave volume. Volume for notifications, warnings, and sounds played by the play track special function. BG volume. Volume for background.wave files music played by the BG music special function. Vario settings. Volume. Volume of the variometer signals. Pitch 0. Low tone frequency. Pitch max. High tone frequency. Repeat 0. Time before the tone repeats in milliseconds. Haptic vibration settings. Mode configures when the radio vibrates. Vibrates when buttons are pressed and for notifications or warnings. No vibrations when pressing buttons or scrolling the wheel, but vibrates for notifications or warnings. Vibrates only for alarms or warning sounds. No vibrations. Strength of the vibration. Alarm settings. Battery low. Voltage to trigger the low battery alarm. Inactivity. Time to trigger the inactivity warning. Memory low. Enables or disables the low memory warning. Sound off. A visual sounds off warning when turning on the transmitter if the sound mode is set to quiet. RSSI shutdown. Checks if a receiver is still connected to the radio when attempting to power off. Creates an audio and visual warning if a receiver is detected. Backlight settings. Always off. Turns on when buttons are pressed. Turns on when using sticks, switches, and pots. Turns on when using buttons, sticks, switches, and pots. Always on. The duration in seconds that the backlight stays on. The minimum value is 5 seconds. The maximum value is 600 seconds. Brightness. Adjust the screen backlight brightness level. Alarm. The backlight turns on when there are alarms or warnings. 4 LCD displays, adjust the screen contrast. 4 OLED displays, adjust the OLED brightness level. Splash screen, duration for displaying the splash screen. Startup sound, on or off switch for the startup sound. Power on delay, delay between pressing the power button and the radio turning on. Options 0 seconds, 1 seconds, 2 seconds, 3 seconds. I set mine to 0 seconds so it turns on immediately without waiting. PWR off delay, delay between pressing the power button and the radio turning off. It is recommended to set a delay of at least 1 second to prevent accidentally turning off the radio with an accidental button press. Owner ID, a custom registration ID used only for users with ISRM modules. Time zone, time offset from UTC for the location where the radio is used. Can be configured in 15-minute increments. Adjust RDC, adjusts the transmitter's real-time clock to match the time determined by GPS. The format for displaying GPS coordinates. Country code, used by some receivers to ensure compliance with local RF regulatory requirements. Options America, Japan, Europe. Voice language, the language for the voice pack. This setting and the voice pack folder on the SD card must match for sounds to be played. Units, units of measurement. Options metric or imperial. PPM units, the level of precision for displaying PPM values. Play delay SW mid POS, the minimum time in milliseconds that a switch must be in the middle position before a special function is activated. This is used to prevent the middle position of a 3-position switch from being activated when switching from the low to the high position. USB mode, sets the default action when a USB cable is connected to the data USB port and the radio is on. Options ask, joystick, storage, serial, def chan ord, the default channel order for new models and the trainer screen. Let's move to the next page, global functions. Global functions are special functions that apply to all models on the radio transmitter. They are configured exactly the same way as model-specific special functions, and the same functions are available. Global functions apply to all models on the radio. This means any function configured as global will be active regardless of which model you have selected to control. Special functions apply only to the specific model for which they are configured. This allows you to set up individual parameters for each model separately. The trainer settings screen in the radio settings is used to configure how the master mode radio will process signals from the slave mode radio. It contains the following configuration options for each of the 4 main control inputs AL, ELE, THR, RUD. How the master mode radio will process signals from the slave mode radio. The stick values from the master radio are used, input from the slave radio is not used. Plus equals adds the stick values from the master and slave radios. Equals replaces the stick values from the master radio with the stick values from the slave radio. The percentage of stick travel from the slave radio that is used. Use negative values to reverse the stick direction. Source channel, the channel from the slave radio that is mapped to the control input. Multiplier, this value changes the value of all sticks together. Calibrate, sets the center stick value of the slave radio. Let's move to the next page, hardware settings. The hardware settings screen is where you can configure the hardware parameters of your radio transmitter. It shows all the physical hardware components, sticks, potentiometers, switches, and allows you to modify them. Here, you can also calibrate your sticks and potentiometers. Before you start calibrating, you need to enable all the sliders here in the settings so they are correctly identified during calibration. Find POTS potentiometers. On my radio, S1 is a rotating slider. S2 is the same. S3 for me are separate buttons that I will use for switching something within a range. For stick calibration, use left to right and bottom to top movements, not circular motions. Also, use a normal level of pressure at the endpoints. Excessive pressure at the endpoints can lead to incorrect stick calibration. Potentiometers should also be set to their middle position and then rotated to their extreme positions. All done. Calibrated. Below is a list of inputs for sticks, pots, and switches. Selecting one of the lines for axis, pots, or switches allows you to add a 3-character label to the control, as well as change the control type if needed. Additionally, you can invert the direction of potentiometers by selecting the arrow. What interests me here is the switches parameter. Here, you can limit the number of positions for each switch if needed. For example, change it from 3 to 2. Battery calibration. For the radio to show accurate voltage values on the main screen, you need to measure the battery voltage with a multimeter and enter that value here. The decimal values will be hard to set because the selection roller's step is too large, but I set it slightly higher than what the multimeter shows. RDC BAT stands for real-time clock battery. This battery is responsible for maintaining the correct time and date on your radio transmitter even when the main radio battery is disconnected or discharged. The RDC battery powers the internal clock, allowing it to keep the correct time settings. When enabled, it checks the RDC battery on startup and warns you if the battery voltage is low. Audio mute. When enabled, it puts the transmitter in silent mode until a sound needs to be played. This prevents noise from high-power TX modules from coming through the transmitter's speaker. Internal RF type a duplicate menu that we discussed earlier. Serial port displays a list of available additional serial ports that can be configured and used. The listed ports depend on the radio's hardware. The ports listed below are just examples and may not be present on your radio. The UX one. The first available additional serial port can be configured with the following options. Telemirror. The same telemetry data that goes to the external module is sent to the serial port. Telemetry in. Receives telemetry data via the serial port. SBUS trainer. Connects instructor and student radios via the serial port. Sends or receives data to or from a Lua script. USB VCP. Virtual COM port. This is one of the options offered when you connect your radio to a PC. It is usually set to CLI for radios with internal ExpressLRS RF modules for firmware updates. ADC Filter. The ADC filter is designed for proportional channel sticks, pots, sliders, smoothing out smaller, fast movements that arise from noise in the system's electronics. This filter should usually be disabled for models with flight controllers. The debug section allows you to test and debug analog controls and keys. Debug analog screen. The debug analog screen will show you the data for your analog control sticks, sliders, pots, 6-position switches. There are 2 viewing modes: calibrated analogs and raw analogs, 5 Hz uncalibrated with a frequency of 5 Hz. Debug key screen. The debug key screen will show you the digital data for your keys, switches, trims, and the rotary encoder roller. Custom sounds. Let's make a voice pack for our radio that will blow everyone's mind.
Finish him. Fatality.
It's actually very simple to do. The sound files must have specific characteristics. Audio format wave. Sample rate 32 kHz, 16 kHz, or 8 kHz. Bit depth 8 or 16-bit. Channels mono. Codec PCM compression. Just in case, copy the entire sounds folder. For encoding sounds with these criteria, I liked the free program Audacity. Here's a link to it. Now we need to choose which sounds to replace. To do this, we need to connect our radio to the computer. Select USB storage SD. Go to the sounds folder. My radio's language is English, so I select the EN folder. Then the system folder. To replace a sound, we are interested in the following audio files here. Hello, this is the track that plays when the radio turns on. Let's replace it with something cool. I like this track. I'll take it and paste it into Audacity. Then I click File, then Export Audio. The file name is the same as on the radio hello. Format is wave. Channels are mono. Sample rate 32 kHz. Encoding 16-bit PCM. Done. Now we upload this file to the Sounds Then System folder and overwrite the original. All done, let's check the result. Now let's replace another sound, the one for the throttle warning. It's called Thrallert. For this, I'll choose this track. Now we do the same as before. Now let's take a cool track for when the radio link with the receiver is lost. I'll use this one.
Fatality.
It's called Telemco. For link recovery, I'll take this track. In the folder, it's called Telemuc. You can also replace the track for receiver still connected.
Finish him.
It's called Modelper. I'll replace it with this one. In this simple way, you can create the custom tracks you want instead of the boring standard ones.